are still working on solving equations with variables on both sides. This is 1.3. So we're going to use inverse operations to solve still linear equations, but the reason we're 1.3 is now introducing more than one solution. So all of our equations have had one solution, right? X equals 4, x equals 13 over 2, whatever it is. But now we have two other kind of versions. We have what's called infinite many solutions, or you'll see in the book, we'll call it identity. This is when the equation is true for all values of the variable. It has infinite many solutions. So we kind of saw that in our quizzes the other day, where it will always work no matter what I put into it, okay? And then the other one is going to be no solution, but we also have seen that a little bit where nothing will work, okay? So we're just introducing different kinds of solutions. So we're going to solve this x, and we're going to talk about how many solutions it has. So first thing I'm going to do is I'm going to distribute. And at the same time, I'm actually going to combine like terms here. So we're going to get 7x take away 10 equals negative 2x plus 8. Don't forget negative and a negative. And then we're going to get plus 9. So now I have 7x minus 10 equals negative 2x plus 17, right? I combine like terms right here. So we need to move our variables together. I always move my smaller variable, which one has a lesser value. So we get 9x minus 10 equals 17. I'm going to add 10 to both sides. We're going to get 9x equals 27. Divide by 9. We get x equals 3. This is a one solution. One number works. Okay, so when it says what's the value of x, it's 3. How many solutions? 1. Only one number works for this equation to make both sides actually equal to each other. To make them true is 3. So that's why it's a one solution. All right, so maybe pause here, see if you can solve this one, and then we'll go over it. So again, I would distribute first. So this gets me half n negative 2, right, because half of 4, minus 7 equals negative 2n plus 6. Maybe combine like terms before we do anything else. Half n minus 9, right, negative and negative, bigger negative. Now, I would like to get rid of my fraction, so I'm going to times this whole thing by 2. Get rid of this. N minus 18 equals negative 4n, and then plus 12. Get rid of that fraction. So whole thing gets multiplied just so I can get rid of that. So I'm going to go minus n, negative 18 equals negative 5n plus 12. We're going to minus 12. And we get negative 30 equals negative 5n. Divide by negative 5. And a negative divided by a negative is a positive. So we're going to get n. Actually, hold on, I'm going to write it the other way. I'm going to keep it always the same. So I'm going to put 6 equals n. Just that way it's always written the same form, right? This side's 6, this side's n. And again, this is a one solution because only one number works to make the whole thing true. We got an answer. We got n equaled 6. All right. So again, maybe pause, try this one out, see if you can get what the value of x is and how many solutions we have. So hopefully you distributed first. We get 4x plus 6 equals 4x plus 6. So you actually could stop here and just say infinity, or as the book says it now, identity. Can't spell identity. There we go. That's because everything's going to work. See how this side is perfectly and identical to this side? Everything's going to work. Now, the other way to do it is, probably should rewrite it here, probably should have done this first, but that's okay, is to fully, get rid of this, like we normally would, and we would get 6 equals 6. You can also stop there, see? This is always going to happen. This is why it's called identity. 6 is always equal to 6, so that's why everything works. It doesn't matter what I put in. They're going to both be the same. Okay? So either works. You can stop here, right? They're both the same, or you can solve it down to here where your variables disappear. All right, so again, pause. Let's have you guys practice. Do 1, check it out. Then pause again, do 2, check it out. And then see how you did. Remember, if you have any questions or concerns when we get back into class, put some stars next to those ones that you need some extra assistance on. All right, so I'm going to combine like terms and distribute at the same time. 6y minus 7 equals negative 3y plus 3 minus 1. I'm going to get 6y minus 7 equals negative 3y plus 2. Add this 3y. 9y minus 7 equals 2. Add 7. 9y equals, oops, add 7, 9. Divide by 9. Y equals 1. One solution. All right, double distribute. So we distribute here and here. We can do it in 1. So negative 5a minus 6 equals 6a plus 16. I'm going to add 5a. We get negative 6 equals 11a plus 16 minus my 16. So that's 12, and so negative 22, 11a, divide by 11. We should have gotten negative 2 equals a. One solution. All right, so here's some more practice now with decimals and fractions. So again, do 5, pause, try it out, see how you did, check out my work, then pause again after and do 6. So I would add my 4 2/10b, maybe just get those variables together. Like I said, you don't have to get rid of the decimals with that trick from our last video. So 6, 7, 8, and 9, so 9 and 8/10b minus 3. Maybe now you want to times by 10. It's nice, it is just 10. Get rid of those decimals. So 68 equals 98b minus 30. So we're going to add 30. And we get 98 equals 98b, divide by 98. And 1 equals b. See how I always like to keep my variable where it is? And again, this is just one solution. All right, I'm going to get rid of my fractions. So I'm going to just times this by 3, get rid of those. It'll be easier for me to see. So I'm going to get 3 plus 2m equals 2m minus 2. So I'm going to subtract my 2m. And I get 3 equals negative 2. Is that ever going to be true? Can 3 ever equal negative 2? No. So this is a no solution, because no matter what I plug in, nothing's going to work. If you also think about it, if I have 2m here and I add 3, how can I take 2m and subtract 2 and get the exact same thing? How can I have $10 and add $3 to it and take $10 and subtract $2 from it and still get the same thing? I can't. So I can never take 2m and do 2 things to it. I'm doing 2 different things to it. All right, I'm subtracting 2 and I'm adding 3. That's why it's going to also be no solution. All right, independent practice. This one we'll go over in class when you guys return. I know you did a lot of pausing and stuff for this, but this one I'm not going to go over. So what is the solution if there is one? And then how many solutions are there? Is it 1, none, or identity. I'm going to continue using that word since that's the word they use in our book. All right, until next time.